Hi, my name is Brandon Graysley. I'm a high school math teacher. Let's talk about how to solve quadratic equations. So here's a quadratic relation. It's a relationship between x and this function f of x. So that is a relation. Well, let's try to get the focus good here. Let's see if that'll stay put. So there's a relation, and an equation might be, well, I want to try to find x so that f of x equals, let's say, 14. So if I substitute the value of 14 in for x, I now have an equation that I can solve. See how it has one variable x? I can solve this to find out which values of x will make this true. So let me just reorganize this thing. I'm going to subtract 14 from both sides, and I think I'll also rewrite things on the left here. People tend to be more comfortable with that. It's going to be that. That'll be the equivalent expression, equivalent equation. So now let's factor this part of the equation. You might wonder, why did I clean this up? Well, if we had factored right here, we would have ended up with 14 equals something times something. And I can think of a zillion different ways that that could work out. But here I'm going to factor two things, will multiply together to equal 0. And that can only happen in one of two ways. So let me start by factoring this. This looks like x minus 6 and x plus 1. So these are those two factors I was talking about. Got one there and one here. When these two numbers are multiplied together, we get 0. So one of these two numbers, or both I suppose, but in this case one of each of these two numbers must be 0. So x minus 6 equals 0, or x plus 1 equals 0. That is, x equals positive 6, or x equals negative 1. So these are the two solutions, and we would write something like f of x equals 14 when, you can say x equals 6, and you can use the word and or the word or. So I could maybe write it like this: f of x equals 14 when x equals 6 and when x equals negative 1. If you say or, that might be a little bit better. It's clear that they don't have to happen at the same time. Okay, so that is how we factor. Remember, really important here, this has to be 0 for this to work. Otherwise, I could think of lots of different pairs of numbers that multiply together to give me a non-zero number. There are infinitely many of those. Okay, let's try a new function. Let's call this one g of x. And this one's going to be x minus 5 squared. And maybe we'll throw in a minus 1. How's that look? Okay. And let's try to find out what x values will work. Find x when g of x equals, when g of x equals 1. Yeah, that sounds good. So we have 1 equals x minus 5 squared minus 1. So I've substituted this value in for g of x, and I now have an equation that I can try to solve. Now you might be tempted to just multiply this guy out here through binomial multiplication and then put everything on one side equals 0 like we did in the last example. But this one, because it's in vertex form, it's actually a little easier to solve in some ways. So we can solve this without factoring, which I know a lot of people will be happy about. Because we have a perfect square sitting here and then just numbers for the rest, no x's anywhere else, we can just put all of our constants on one side and leave this square thing on the right hand side. So I'm going to add 1 to both sides. I'll end up with 2 over here. 1 plus this 1 is 2 equals x minus 5 squared. And now we can take the square root of each side. When we do that, on this side we're going to end up with x minus 5. I'm going to leave the brackets for now. On this side we have the square root of 2. And we have to put a plus or minus either here or here. This thing could be positive or negative. See, it got squared there. So I'm going to just put the plus or minus right there. as I say, it could go right there, plus or minus here instead. That would be fine. Now I'm going to start to simplify. So plus or minus root 2 over here. And on this side, I've got x minus 5. Again, the brackets aren't really necessary since nothing's being multiplied or divided or anything. I'm going to add 5 to both sides, and I'm just going to stick that over here as a positive 5. So I've added this 5 to both sides of the equation. It clears out over here, and it's left over on this side. So x is 5 plus or minus root 2. We can write that in two separate equations if we like. X is 5 plus root 2, or, that word or, you say it right here, plus or minus, there's the or. X equals 5 minus root 2. So those are the two solutions. We could also write decimal approximations. 5 plus root 2 is about 6.41, and 5 minus root 2 is about 3.59. Notice I put a little dot above my equal sign to show that this is an approximation. Okay, we're doing well. One more. This one is not going to be in as nice a form. Well, it's going to be in standard form, but it is not factorable. And you would only know that by sort of trying it out, I suppose. You could work on factoring it, but this one will not work out to nice factors. Okay, let's try that. And once again, let's find x when, in this case, k of x equals 1. So let's substitute that in. K of x is 1, so we have 2x plus 4x minus 4 is equal to 1. And reorganizing this, I'm going to put everything on the left-hand side of the equation, but we're going to have a minus 5 here. Now this is in standard form now. It equals 0. Very important. You can't work with it when it's in this in these two pieces here. So we usually call these A, B, and C. There's A, B, and C. Notice that C is negative 5. The other two are both positive. And this is a great time to open the quadratic formula from your toolbox. Quadratic formula is this: negative b plus or minus blah blah blah. A, B, and C here are the parameters that I've listed in the standard form. You have to have standard form equals 0. If you had anything left over here, like this 1, that would change what C is. And so you have to simplify to get this form first before you can use the quadratic formula. The formula tells us all of the solutions to this equation. That's what it's for. It essentially comes from converting this to vertex form and doing what we did in the last example. In any case, x equals, let's see, negative b is negative 4, because b is 4. And we're going to have 4 squared minus 4 times a is positive 2, and c is negative 5. Really important that you get that negative in there. And 2 times a is 2. So let me just simplify this. Negative 4 plus or minus. We've got 16 there. That's always going to be a positive number when b gets squared. And then negative, let's see, 8 and times 5 is 40. That's going to actually be positive. Negative, negative, this is plus 40, all over 4. And let's see now. We have, is that right? Yeah, I think so. Negative 4 plus or minus square root of 56 all over 4. Now to simplify this number 56 is an entire radical, but we could write it as a mixed radical, because this is 8 times 7, or it's 4 times 14, right? So maybe I'll write it as two radicals first. It's square root of 4 times the square root of 14. All of that's divided by 4. And then 14 is 7 times 2, which it has no perfect squares in it. So this is negative 4 plus or minus 2 root 14 over 4. I'm really running low on paper here, but I'm going to go to the next page in just a second. To simplify this, negative 4 over positive 4 is 1, so x equals 1 plus or minus, and then 2 over the 4 is 1/2. So I'm still going to have root 14 all over 2, or I could write 1/2 times root 14. Okay, 1 plus or minus root 14 over 2. Let's finish this off. I'll rewrite that. 1 plus or minus root 14 over 2. Writing it as two separate statements, I've got 1 plus root 14 over 2, or I've got x equals 1 minus root 14 over 2. And I don't have those calculations handy with me right now, but those are the two solutions. So we can say k of x equals, oh, I've forgotten now, 1, sorry, k of x equals 1 when x equals 1 plus or minus root 14 over 2. Now very often, like in this example, you'll get some number here that isn't reasonable for the situation that you're describing. For example, maybe you've got some ballistic trajectory thing where something's flying through the air, and so you've got an equation where somebody throws something and then it hits the ground. Well, and you want to know at what point is it this high off the ground. When you solve the equation that goes with this, you'll end up with this solution, which is great, but you'll also probably end up with another solution over here, which is, not great. That's not reasonable or not admissible. And that solution over there, we would say is inadmissible, and you can't provide it as an answer. You might also see the words like invalid or inappropriate or extraneous is another word that you'll see a lot. It's an extra that we don't need. This one is probably the most common way to say it, an inadmissible solution. So in a real situation where if you know the domain, for example, this domain is when x has to be greater than 0, and also x is less than or equal to whatever this value is, maybe it's like 10, then the domain is restricted, and so you have to pay attention to that to see which values that you get as solutions are actually inside of the domain and are reasonable. Okay, so 3 methods for solving quadratics. You can set everything to 0 and factor. You can use the vertex form and take the square root of both sides, or you can put everything in standard form and use the quadratic formula. Okay, I hope that's been helpful. Good luck, and I'll talk to you soon. Bye.